In this video, we're going to talk about mean value theorem for derivatives. Before we do that, f prime of c represents instantaneous rate of change at x equals c. And what about this portion right here? F of b minus f of a all over b minus a. That represents rate of change or slope at x equals a and x equals b. So, mean value theorem states that if y equals f of x is continuous at every point of the closed interval a to b and differentiable. What do you mean by differentiable? It means that you're able to find the derivative or find the slope at every point of its interior a to b, then there is at least one point c in a to b at which the instantaneous rate of change equals the mean rate of change. So graphically, what does it mean? We have A and B. So the graph going through A and B is this portion right here. Now, there are two conditions. Is this continuous? Yes, it is. From A to B, that's continuous. And is it differentiable? It's a smooth curve, so it is differentiable. You're able to find the slope from A to B. So those two conditions are met. Now, then it guarantees that there's a C such that C is between A and B, so that f prime of C is equal to f of B minus f of A all over B minus A. So what does it mean? What is it? F of B minus f of A over B minus A? That is the slope of the line connecting point A and point B. So f of A represents the y value at x equals A, and f of B represents the y value when x equals B. So if there is a slope of this line going through A and B, then that guarantees that there's a C between A and B such that f prime of C, which is the slope of f at x equals C, is also equal to the slope of this line connecting point A and connecting B. Now we only have one C here, but the theorem says there could be at least one C, which means there could be more than one, depending on the graph. Now here are two cases where mean value theorem cannot be applied. Over here, look at from A to B. It is continuous. However, it's not differentiable from A to B. It's not differentiable when x equals 0 here. It's a sharp turn. So you cannot apply mean value theorem. What about this one? This is not continuous at x equals B. So you cannot apply mean value theorem. Those two conditions must satisfy. Let's take a look at this example. It says show that the function f of x equals x squared satisfies the hypothesis of the mean value theorem on the interval from 0 to 2. Then find the solution C to the equation. First, let's see if satisfy the two conditions. When you look at x squared, the graph looks something like this. And when you look at from 0 to 2, it is continuous and it is differentiable. So it satisfies the two hypotheses of mean value theorem. Now, how are we going to find C? Well, we first need to find the derivative of f of x, which is 2x. So according to the mean value theorem, there has to be f prime of c, which is equal to f of b minus f of a all over b minus a. Now, what is f of our a is 0, and our b is going to be 2. So basically what we need to find is, we need to find, instead of c, instead of x, we're going to substitute c, and f prime of c is going to be 2c. So 2c is equal to, what is f of b? That's f of 2, which is going to be 4. 2 squared is 4, minus, what is f of a? Our a is 0. F of 0 is going to be 0. All over b minus a, which is 2 minus 0. Now that becomes 2c equals 2, which implies that c is equal to 1. And is 1 between 0 to 2? Yes, it is. It's within the interval. So what does this mean graphically? So graphically, this is what it means. You have y equals x squared, the blue line, and a is 0 and b is 2. So when you connect these 2 points, the slope of this line is going to be 2. The slope of this line will be 2. And when x equals 1, which was our c, the slope of this tangent line at x equals c is also going to be 2. And these two lines are parallel because they have the same slope. In this example, it wants you to explain why each of the following functions fail to satisfy the condition of the mean value theorem on the interval from -1 to 1. In order to do this, you want to graph both of these using your graphing calculator. Part A is pretty simple to graph. Part B is a piecewise function, and if you forgot how to graph piecewise function, I have a playlist how to graph function using graphing calculator, TI-84 plus CE. So you might want to check that out if you forgot how to graph or do not know how to graph piecewise function. You might want to check it out. So using your graphing calculator, you should have got something like these two. Well, the part A, when you look at it from -1 to 1, it is continuous from -1 to 1. However, it's not differentiable at this point because there is a sharp turn. So that's why it doesn't satisfy the hypothesis. What about graph B, the piecewise function? From -1 to 1, it is differentiable from A to B. However, it's not continuous at B. It's disconnected. Therefore, you cannot apply mean value theorem. Now let f of x equals square root of 1 minus x squared, which is a semicircle. And a is -1 comma f of -1, which is over here. That's going to be our point A. And b is 1 comma f of 1, which is over here. That's going to be our point B. Find a tangent to f in the interval -1 and 1, -1 to 1. This is an interval. It's not a point. That is parallel to the secant AB. So what is the slope of this line connecting point A and connecting point B? The slope is 0. So basically we need to find where between -1 and 1, the line that is tangent to this curve will have a slope of 0. In order to do that, we need to find the derivative of f of x. So let's rewrite f of x as quantity 1 minus x squared to the 1/2. And what's the derivative of that? That's going to be 1/2 quantity 1 minus x squared, -1/2. Don't forget the chain rule. You got to take the derivative of inside, which is -2x. So you get 2 cancels out, 1 over 2 and 2 cancels out. You get negative x over radical 1 minus x squared. F prime of c is going to be negative c over radical 1 minus c squared. And using the mean value theorem, negative c over radical 1 minus c squared is equal to f of b, which is going to be 0, minus f of a, which is also 0, over 1 minus negative 1. Because our a was negative 1 and b was 1. That was the interval. And by the way, this satisfies the two hypotheses mean value theorem. It is continuous from a to b, and also it is differentiable between a and b. So it satisfies both conditions. So how do you find the value of c? Well, this is going to be 0, right? So negative c over radical 1 minus c squared is equal to 0. And in order to solve this, let's cross multiply. You get negative c is equal to 0. Therefore, c is equal to 0. So what does it mean? It means when x equals 0, the slope of that tangent line to this curve will be 0, which is parallel to this line connecting A and B. So what is the equation of that tangent line? Well, the slope is 0, and the point when x equals 0, the y value is 1. Just plug it into the equation. So what is the equation of this line? It's going to be y minus 1 equals 0 times x minus 0. This implies that y is equal to 1. So that's going to be the equation of this tangent line. Now you got f of x equals x cubed minus 3x plus 5. And we're looking at the interval from negative 1 to 1. Does this satisfy mean value theorem? It does, because this is a polynomial. And you know that polynomial is continuous and differentiable. So you might want to check with your calculator to confirm it. Now, since it satisfies the mean value theorem, where can we find c such that f prime of c is equal to f of b minus f of a all over b minus a? So let's find f of b. F of b is the same thing as f of 1 in this case. It's going to be, plug it in 1 for x. You're going to get 1 minus 3 plus 5, which is going to be 3. What about f of a, which is f of negative 1 in this case? It will be quantity negative 1 to the third plus 3 plus 5, which is negative 1 plus 8, 7. Now we got to find f prime of c. So that is a derivative of f of x. So f prime of c is going to be 3c squared minus 3. Now we got to set it equal to each other. So we got to find 3c squared minus 3 equals f of b, which is 3 minus f of a, 7, over b minus a, which is 1 minus negative 1. And that equals to negative 4 over 2, which is negative 2. So we got to find 3c squared minus 3 equals negative 2. 3c squared is equal to 1. Divide both sides by 3. You get c squared equals 1 over 3. Therefore, c is equal to positive negative radical 1 over 3. Now, both positive and negative radical 1 over 3 is between negative 1 and 1. So therefore, in this case, we have two c's. So we have two c's such that f prime of c will equal to the rate of change from A to B. Now again, you might want to graph this and see what happens when c is equal to positive negative radical 1 over 3 and see if the tangent line at those 2 points at this curve is parallel to the average rate of change of A and B.